Hello everybody. What we're going to be talking about today is kind of a follow-up to the rational root theorem. What we were able to accomplish there was identifying what are the potential roots of a polynomial so that way we could work through a list and see what worked and what didn't work as far as identifying the factors and the solutions of a polynomial when they're not given to us at the beginning. So this one here is allowing us to identify a little bit of narrowing down what some of those factors are going to be. In the rational root theorem, I mentioned something about a little rule that old-time mathematician named Descartes gave us as far as being able to identify what are the positive roots and what are the negative roots, or how many of each kind that we would have. And here what we're going to do is we're going to be able to narrow it down specifically to a couple of numbers, whether a positive one or a negative one is a factor of a polynomial. So here what it's telling you to do is still says create a list of the potential factors. Now I'm not actually going to do that first. I'm going to probably do that second. First thing I want to do is see is 1 a 0 and if negative 1 is a 0. So make sure you get this second part copied down here as far as the guide that it tells you how to identify if a positive 1 or a negative 1 is a root. So let's go ahead and take a look at our next step here. And this is just, again, if negative 1 is a root, what you have to do. In order to tell if negative 1 is a root, this is kind of the important part here. We have to switch the signs on the odd-powered terms, meaning, like, let's say, for instance, we have f of x is equal to 2x to the fourth minus 3x cubed plus 4x squared minus 8x plus 10. Okay, when it says identify the coefficients and switch the terms of the odd powers, well, what we would do is when we're checking it is we just take the coefficients. Well, the first term is an exponent to a 4, so that's an even number, so we just leave it alone. The next one is x to the third. That is an odd power, or an odd numbered power. So what this rule here is telling you to do is to take whatever the coefficient is and change the sign when we're adding it. So then we're going to say the next one is an even numbered power. The next one is another odd numbered power, so I changed the sign on that one, and so on. That's what that third part is telling you to do. And then part 4 says, okay, well, now that you can tell if 1 or negative 1 is a 0, then just finish factoring it. So here we have our first example, and what it says, again, the first thing I want to do is I'm going to kind of off to the side here, I'm going to do a check to see is the number 1 going to work? So if we take the coefficients and the 1 constant of this fourth degree polynomial, we would have a 1, a negative 23, a negative 18, and a positive 40. If we add all of those together, it gives me a 0. So that tells me that x equals 1, or the factor x minus 1 is going to work for this particular function. And so now we would check the negative 1. Okay, does negative 1 also give us a function? Because if it did, that would give us 2 out of the 4 factors that we would need. Now, the third thing that you had written down says, okay, well, we have to change the signs of the odd numbered powers, meaning we have to change the positives to negatives or whatever of the coefficients of the odd numbered powers. Well, x to the fourth is an even numbered power, so it stays the same. X squared is another even numbered power, so the negative 23 stays the same. X to the first is an odd numbered power, so I'm going to change that negative 18 to a positive 18, and then the 40 is still just 40. And when we add those together, that gives us a 36. So that means x will not equal negative 1, and the factor x plus 1 will not be a factor of the fourth degree polynomial. Okay, so at least we've established that we have one of the three terms identified for us. So let's go ahead and we could go ahead and do our division with that. Now I'm going to go ahead and see. So that was actually the first step that it told you to do. First thing it told you to do is identify your potential factors, but I'm going to do that next. So the potential factors of this fourth degree polynomial, the factors of 40, 1 in 40, 2, 20, 3 doesn't work, 4 and 10, 5 and 8, and that's pretty much it. At that point, we would start repeating ourselves. And the factors of here are just 1. So let's go ahead and see what we can see. We're going to say P over Q, and all of the potential factors, again, I'm going to start with the smallest number of my P values and compare it to the 1 of the Q value. So 1 over 1 would be a positive or a negative 1, but we know the negative 1 doesn't work. So let's see, next one, positive negative 2, positive negative 4, positive negative 5, positive negative 8, positive negative 10, and 20, and 40. So those are all the potential factors that we have here. Okay. Now, again, off to the side here, I'm going to use the little use Descartes' rule to see, okay, well, what types of numbers should I have? We know we have one positive number. Is that the only positive number that we need? So if I substitute a positive number into the function, well, positive number raised to the fourth power is positive. Positive number raised to the second power is positive, but multiplied by negative 23 would be a negative. Negative times a positive in the next term would be negative. And then we have a positive 40. So we have one sign change here and another sign change here. So that tells me that there's two positive numbers that we could use as a root here. And we already got one of them, so that means there's one more. So if there's two positive numbers, odds are there's two negative numbers. Now, it's possible that they could be imaginary, but let's go ahead and run through it and see what we can get here. If we substitute a negative number raised to an even power is positive. The next one, again, would give me a negative number. Negative and a negative will give me a positive, and then we have a positive. So we have one here and a one here. So there's two numbers that are negative as well. Now at this point, it's kind of up to us to see, okay, well, what do we want to do with this? So we know that the 1 is going to work. So let's go ahead and take the 1 and simplify the fourth degree polynomial. Go ahead and do your division with the positive 1. Now, again, look at your exponents. 4, the exponent of 3 is missing, so we need a 0 placeholder. So 1, 0, negative 23, negative 18, and 40. Okay, let's see what we get here as we do this one. Now, according to what this rule is telling us, 1 better work. So when I go through the division here, I should have a 0 as a remainder. Bring down the 1, multiply, add, multiply, add, multiply, or add and then multiply one more time, and we do have a remainder of 0, so that works. Now, if we were going to look at that quotient, we would have x cubed plus x squared minus 22x minus 40. Now, at this point, we can factor some third degree polynomials by grouping. Okay, so if we tried factoring this one by grouping, we would get x squared times x plus 1, and here the only thing that they have in common really is a 2, so I would say minus 2 times x minus or plus 10, or 20 rather. And you can see that this function here and this function here do not, or this expression I should say, they don't match, so we can't really factor this one by grouping, unfortunately. So the only other thing that we can really do at this point is to try and continue dividing. meaning we have to look at all the other potential factors. Now, we know that we should have, using the Descartes' little rule here, we know we have to have two positive numbers at work and two negative numbers at work. So it's kind of up to you whether you think my odds are better trying to get another positive number since we've already worked through one, or if I want to use the negative numbers since I know that there has to be two that work and we've already eliminated -1. So it's kind of up to you at this point. I'm going to just go ahead and stick with the positive numbers because I started with positive numbers. Multiplying with positive numbers makes it less likely for me to miss a sign. So the next positive number would be 2. Now we're going to do our division with the simplified polynomial, meaning I'm going to take the quotient of the first division and use that for my second division. So let's see what we get here. Bring down the 1, 2, 3, 6, -16, and that would be a -32, and that unfortunately does not equal 0. So 2 did not work. Okay, so let's go to let's try our next one here and see what happens. So the next whole number would be a 4. So let's try 4. 1, 4, 5, 20, -2, and that would be -8, so that would be -48, so that doesn't work either. Okay, so 4 didn't work. All right, maybe I should have started with the negatives. I don't know. Let's see what we get here. Let's go to the next positive number, so 5. So we have 1, 5, 6, 30, and that would be an 8. And oh, hey, 8 times 5 is a positive 40. So that works. So here I can say x is going to equal 5, and the factor would be x minus 5. So we have something that works. Awesome. So now I have this one would be x squared plus 6x plus 8 as a secondary simplified polynomial. And that one we can factor. This polynomial can be factored with an x plus a 4 and an x plus a 2. And that's where the two negative numbers that Descartes' rule said we should have would come from. So we have one factor here, two factors. So let's go ahead and write this out as our factored polynomial. So I'm going to go ahead and do it in the order that I found them in. So the first one that we had was x minus 1. The next one that I found was x minus 5. And the last two that I found were x plus 4 and x plus 2. So that's what it would be in factored form. So that's one of the things it's asking us to do. And what are all of the zeros? Well, all of the zeros are the solutions that come from those factors. So we already know positive 1 is. Now we know positive 5 is, -4, and -2. So this is what we're kind of looking for. And again, knowing that we have at least one root with which to start, in this case a positive one, it does help a little bit in identifying what we're going to simplify. But so let's go ahead and try this one here. Again, the first thing I want to do is see, is positive 1 or -1 a root? Because if they are, that helps, because I'm only looking for 3 roots. And if one's positive 1 and one's -1, then that really helps me, simplify things. So let's check for positive 1. So we're going to just take the coefficients, the 3, the -14, the 17, which is positive, and a -6. Add those all together, and we get 0. So that works. So that means x has to equal to a 1, and the factor would be x minus 1. So we have one of our factors. So now let's just check real quick for -1. So we have to change the signs of the coefficients of the odd numbered powers. So x to the third is an odd numbered power, so I'm going to change the positive 3 to a -3. And then the -14 is even, so that stays the same. 17 has an odd numbered power, so it becomes -17, and then -6. And clearly, everything is negative, so that's definitely not going to be a 0. In fact, all those combine to be negative 40. So unfortunately, only one worked again. So we have the positive one that works. So let's see what our list of factors are going to be. So 1 and a 6, 2 and a 3. So at least it's a small number. We have a 1 and a 3 here. So we're not going to have too many. So let's go ahead and write out what our factors of P and Q. So 1 over 1 is a positive or negative 1, 2, and then positive negative 3, positive negative 6, and let's do the fractions. So we have 1 over 3, positive or negative, 2 over 3, positive or negative, and then 3 over 3 would be 1, so we don't write that down again because that would just repeat, and 6 over 3 would actually be 2, so that's also going to repeat. So here are the list of the factors that we should have. All right, so let's go ahead and break this guy down and see what we get. So we know 1 works, so let's go ahead and divide by 1. Try and get a simplified polynomial and see what we get. So there's no exponents missing, so we don't need any 0 placeholders. So 3 minus 14, positive 17, minus 6. So let's see what this simplified polynomial will give us. So we have 3 and negative 9, I'm sorry, negative 11, and that would be negative 11, which would be a 6, and 6, and 0. Okay. Now, real quick off to the side here, because I forgot to do it a second ago, let's go ahead and check what types of numbers should I have. Okay, so positive numbers, okay, so if I substitute a positive number into the function f here, 3, if I substitute something to the third power, that's positive, so positive 3 times a positive number is positive. Negative times a positive number would be negative. Positive times positive would be positive, and then negative. So we have 1, 2, 3 sign changes here. So there's 3 positive numbers. So because there's 3 positive numbers, Descartes' rule is telling us, well, we have to have 3 factors, and Descartes' rule is telling us that we have to have 3 positive numbers. So I'm not even going to worry about trying to check any negative numbers on this one. So I'm glad I looked at that because now I don't have to worry about negative numbers. Okay, so let's see what we have here. So this would give us a simplified polynomial of 3x squared minus 11x plus 6. So we want to say, okay, well, can we continue to divide that? So, well, let's go. So we know we're not going to look at any of the negative numbers because that's what Descartes' little trick taught us. So there's nothing else to do with 1. So let's try 2. So 3, negative 11, and 6. So 3, 6, negative 5, negative 10, negative 4. So that doesn't work. All right, so let's try the next positive number. So the next positive number would be a 3. All right, so bring down the 3, 9, negative 2. Hey, look. And so that would be negative 6. So that one works. So here I know x has to equal 3 as a solution, and the factor would be x minus 3. And this simplified polynomial here would just be 3x minus 2. So that is my third factor. So we can say f of x is equal to, let's go ahead and do it in the order that we found them in, x minus 1. The next one was x minus 3, and the last one was 3x minus 2. And so the zeros would be x is equal to 1, 3, and 2/3, which, you know, we can't just not discount those fractions when it comes to identifying what are the possible roots. Now, the only other thing that I want to kind of identify here, this is a, at this point right here, we had a simplified polynomial that gave us a quadratic of 3x squared minus 11x plus 6. Now, if you recall, you know, the discriminant of the quadratic formula, b squared minus 4ac, that will allow you to identify, can I factor this, or do I just need to do some more division or something? So here, if we said negative 11 squared minus 4 times 3 times 6, that gives us a discriminant of, I don't remember, I didn't, 49, here we go. So this is a perfect square, so that tells me that this function here, the 3x squared minus 11x plus 6, it should be factorable. Now here's a little trick that I do when I'm factoring a quadratic where the a term is greater than 1. I'm going to take that 3, multiply it here to the 6, and drop it off of the first term for the time being. So I'm going to say x squared minus 11x plus 18. And we can see pretty easily that this is going to be factored to be an x minus a 9 times an x plus a 2. Well, now we reintroduce the 3 as x minus 9 over 3 and x plus 2 over 3. And if they can simplify, they simplify. So x minus 3, and this doesn't simplify, so we would just write it as 3x, oops, I don't know why, minus 2. And that gives us the same two factors that we had there. So again, I just want to reiterate that we can still keep doing the division with the potential roots that we have, or if once we get it down to a quadratic, we should be able to identify if we can factor it or not. Maybe one will be easier than another sometimes. I don't know, but it's just another tool to have in your bag to make sure that you pay attention to it. So there's the tricks that we're looking at to see is positive 1 or negative 1 going to work, and that can help us identify where to start with when we're looking at a list of factors. So as always, make sure you have any questions that you need written down. Bring them to me in class if you're not sure about anything, and we'll see you guys soon.